Question 1. So find the class interval that contains the median. Well, the median is going to be the middle child. There are 80 children, so the 40th child is the middle one. So these are the children building up. So here are 4 children, here's another 11, so we've now got to 15 children. There's another 24, so adding that on we've now got to 39 children. Still haven't got to our 40th child, so our child is in this row here. So our 40th child is one of these 22 here. So the height class, the class interval for the height, we just copy that down. Now for part B, draw a frequency polygon. Well, for the frequency polygon, you plot the midpoint of height. So these are all the midpoints of the heights and the frequencies. So we plotted 135, 4, 145, 11, 155, 24, 165, 22 and 175, 19. And then you draw these points, you can connect these points just with straight lines. So it's a straight line graph. Question 2. Well, there are many ways to answer this question, but you just basically got to end up with comparing like with like. So I've stuck with how we have it for London. So 1 litre costing 108.9 pennies, and I'm going to go and change New York to be in litres and pennies so we can compare like with like. So in New York we've got 1 gallon being $2.83. So the first thing to take on board is 1 gallon is 3.785 litres. So this 1 gallon costing $2.83 is 3.785 litres costing $2.83. So if I want to get back to what 1 litre is, I've got to divide by 3.785. So 2.83 divided by 3.785 gives me $0.74 and a bit cents. So that's how much 1 litre costs. Now I want to turn the dollars into pounds. Now going dollars to pounds, we've got to get smaller. You can see the numbers getting smaller. So we're going to have to divide by 1.46. So I've taken my 0.747 and divided by 1.46 to get 1 litre costing. Question 3. So I think the key bit here is to appreciate that we've got kilograms up here, but this density is in grams per centimetres cubed. So really the first step needs to be to convert these kilograms into grams. So multiply this by 1,000. So the gold bar has a mass of 12,500 grams. Now density equals mass over volume. So rearranging to make volume the subject, you multiply by V, divide by D. So for volume equals mass over density. So the 12,500 divided by the 19.3. We are now comparing like with like because they're both in grams. That gives us 647.66 ... So to 3 significant figures, that's 648. Question 4. So we've got blue, green and red pens. We're told the ratio of blue to green is 2 to 5 and green to red is 4 to 1. Now the secret here is to make the, really to have a common denominator if you like, thinking of it like fractions. We want to make this green number of pens the same for both. so that we can get a three-way ratio. So if we take this first ratio and choose to multiply that by 4, and then take the second ratio and choose to multiply that by 5, we end up with 20 green pens for both. So we can now compare all three. So we have a ratio of 8 to 20 to 5. So 8 to 20 to 5 is the ratio of blue to green to red. Those three together add up to 33. So getting as close as we can to 100 pens, we can multiply across by 3, giving us 24 blue, 60 green, 15 red, 99 pens in total. So what is the greatest possible number of red pens in the box, given that the total's got to be less than 100? Well, it's 15. Question 5. So the reciprocal of a number is just 1 divided by the number itself. So it's just literally 1 over 1.6, which is 0.625. If you want to sort of work it through without relying on your calculator, obviously 1.6 is 1 6/10, which is 16 over 10. Flip it over, you get 10 over 16, which is 0.625. Now, for part B, just round the number x to one decimal place, the result is 9.8. Write down the error interval for x. So really, we're just looking for the upper bound and the lower bound when we round to one decimal place. So the upper bound is 9.85, lower bound is 9.75. But remember, if we're exactly 9.75, we round up. So we want to include the 9.75. But at 9.85 you would go up to 9.9, so that's why that one is less than only, yet the other one is greater than or equal to. Question 6. So we're told that the length of the rectangle is 7 centimeters longer than the width. So let's just go and make the width be x rather, and therefore the length is x plus 7. So I've worked my way around this shape, writing in whether it's either an x plus 7 or an x. And just be careful, we've got a couple here, here, and here where we actually get 7s, because we've got an x plus 7 less than x, which is a 7. So don't forget those two 7s. So we're told the perimeter of the shape is 70 centimeters. So the length all the way around the outside is 70 centimeters, equal to 70. Now running all the way around the outside, you pick up 8x's and 42 normal numbers. So 8x plus 42 equals 70. Taking away 42 from both sides, dividing by 8, we see that x is 3.5. So just looking at one rectangle, the width is 3.5, the length is 7 centimeters longer at 10.5, so the area of a single rectangle is 3.5 times 10.5. Question 7. Well, given this is a calculator paper, I would just pop this straight into my calculator, and you get 7.452 times 10 to the minus 4. Now we've got to give our answer as an ordinary number, so we have to adjust this. So set up as a workings, your 7.452. It's a minor's power, so we know the number's got to be small, so pop some noughts to the left of the number, and then just hop the decimal point along 4 places. So 1, 2, 3, 4. So the decimal point's going to end up there. So we've got 3 zeros to the right of it. So 0.0007452. Question 8. So whose result would give the best estimate for the probability? Well, the more trials you have, the more likely, the more accurate the answers are going to be. So Mel, as she has the greatest number of throws, because she's had 80 throws in total. Now for part B, it says use all the results in the table to work out an estimate. So all the results, we've got to add Lucy and Mel and Tom's results together. So points down for the 3 add up to 100. Points up for the 3 add to 50. So the probability of a points down is 100 out of 150, which simplifies to 2/3, and the probability of a points up is 50 out of 150, which simplifies to 1/3. Now the probability that the pin will point up the first time and point down the second time, so probability of point up and then point down, is the probability of point up, which is 1/3, multiplied by the probability of a point down, which is 2/3. Top times top, bottom times bottom, that gives us 2/9. Question 9. So we're told that we were trying to work out how many years before Jack's boat is first worth less than 50%. So how long until it's worth less than half of 12,500, which is 6,250. So we're just going to do this by trial and error. So I'm just going to guess n being 4 first of all, so 4 years. So I've done 12,500 times 0.85 to the power of 4, and that's given me 6,525. So still a little bit greater than 6,250. So let's try 5 years. So popping 5 into this, 12,500 times 0.85 to the power of 5. I do now get 5,546, which is less than 6,250. So 5 years is the number of years until I'm first less than 50% of the value of the boat when it was new. Now for part B, we've got a savings account paying a rate of interest. Jack invests this. After tax, he gets £79.20 interest. So after the 40% has been deducted, he gets £79.20. So this represents 60% of his gross interest, of the total interest he had before the 40% was deducted. 40% deducted, 60% not deducted. So if this is 60%, how much did he have interest? Question 10. So part A, I think probably the easiest question on the paper. So what's the probability of getting a red? Well, the probabilities have to add up to a whole. They add up to 1. So add these 3 together, we get 0.95. Deduct that from a whole, we get 0.05. Now, what is the least possible number of counters in the bag? And we give a reason. Well, the probability of a red, we've just worked out to be 0.05, and this is the smallest probability. That is 5 out of 100, which is 1 out of 20. Now we've got to get a whole counter. We can't have part of counters. So if we have 20 counters in the bag, then we would expect to get one. Then we would have 1 red counter, because it would be 1 out of 20. So there must be at least 20 counters in the bag to give us our 1 red counter. Question 11. So for part A, use the graph to find an estimate for the median weight. Well, the median weight is going to be the weight of the middle potato. So we've got 60 potatoes, half of 60 is 30. So we want to work out the weight of our 30th potato. So if we go along on our 30th potato, take a reading of its weight, we get 57 grams. Now, Jamil says 80 minus 40 equals 40, so the range of the weight is 40 grams. Well, that depends on 80 being the highest, the biggest weight of a potato, and 40 being the smallest weight of a potato. But we can't be sure, just looking at it here, that the smallest potato did indeed weigh 40. So Jamil might not be correct, as the minimum weight could be less than 40. Question 12. So we're told the number of times both spinners land on red is 24. So that's really our way into this question. Let's focus on getting a red and then another red. So the probability of a red and then another red, so probability of red is 0.25 times 0.6, which is 0.15. So we need the probability of getting a red to be 0.15. Now we know it happened 24 times, so that's 24 out of how many times to have a probability of 0.15. So rearranging this, we get x being 24 over 0.15. So we need there to be 160 double spins, 160 goes, in order for the probability in order for it to have happened 24 times to both red and red. So 24 divided by 160 is our 0.15. So we know we've had 160 goes. So work out an estimate for the number of times both spinners land on white. Well, we know we're going to have 160 goes. So how many times would we expect to land on white? So the probability of white is 0.7. Question 13, so here we're just completing the square. So the key point is you've got to appreciate your starting point is to have x plus something in the bracket all squared, but we halve the coefficient of the x. So we halve the 6 to get our plus 3. So that's how we've got the x plus 3 all squared. Now if we do x plus 3 all squared, so x plus 3 times x plus 3, we get x squared plus 6x plus 9. Well, we want the x squared plus 6x, we don't want the plus 9 bit, so we back that out by having a minus 9. So what we're saying is, if you expand this bracket and take away 9, that gives you x squared plus 6x. So this equates to this. And then of course we've also got our minus 7. So gathering up these two terms here, we get x plus 3 all squared minus 16. Question 14. So we've got mathematically similar cones, and we're told that the volume ratio is 27 to 8. Now if that is the volume ratio, then the length ratio is the cube root of each of these. We move from volume to length by cube rooting. Cube root of 27 is 3, cube root of 8 is 2. Now moving from the length ratio to the area ratio, we square. So squaring 3 and 2, we get 9 to 4. So this is our area ratio. Now we're told that the area of A is 297. So how do we work out the area of B? Well, we've got to follow this ratio here. So take our 297, divide by 9, multiply by 4. We do indeed get an area of cone B of 132. Question 15. So for part A, to show that we have a solution between these two values, we first of all substitute x into the equation, x being 0 into the equation, and then secondly substitute x being 1 into the equation and look for a change in sign. So when we substitute 0 into the equation, we get minus 5. When we substituted 1 into the equation, we got plus 3. So there's a change of sign, so therefore there must be a solution between x being 0 and x being 1. Now for part B, we've got to show this rearrangement. So let's first of all start off by adding 5 to both sides to give us this. Then we factorise, taking out our x. So we've got x multiplied by x squared plus 7. And then we divide through by our x squared plus 7, giving us x being 5 over x squared plus 7. Now for part C, we just got to use the iteration formula. So we start off by substituting 1 into this formula here. So we have 5 divided by 1 squared plus 7 to give us our x1 value, which is 0.625. Now to work out our x2 value, we substitute our x1 value into the formula. So we do 5 divided by 0.625 squared plus 7, which gives us this 0.676 and so on. And then to work out our x3 value, we just substitute our x2 value into the iteration formula, giving us 0.67044830001. Now, by substituting your answer into your answer to part C into this, comment on the accuracy. So, taking our 0.670448. Question 16. So, could Nathan be wrong? Nathan's saying that his car uses less than 8 litres of petrol per 100 kilometres. So we want to just see, is there a chance that in fact that the petrol consumption is higher than this? So let's work out the upper bound for the petrol consumption. Now, to work out the upper bound when you have a division involved, you want to make the numerator as big as possible. So we're going to take the upper bound for the number of litres of petrol used, the upper bound, but for the denominator we're going to take the lower bound, so the smallest number of kilometres travelled. So substituting in, we have 100 multiplied by the upper bound for the litres used, so our upper bound of our 11.8, which is 11.85, and then we take our lower bound for the number of kilometres driven. The lower bound for 148 to 3 significant figures is 147.5. Popping this into our calculator, we get 8.03 ... Now that's above what Nathan says. So yes, Nathan could be wrong, as the upper bound for petrol consumption is greater than 8 litres of petrol per 100 kilometres. Question 17. So this breaks down into 3 steps really. So first things first, we're told that the area of triangle ADC is 56. So using the area of a triangle rule, half AB sin C, we can work out this length here, CD, because we're saying it's half of 11 times our unknown CD times sin 105, and that gives us an area of 56. So working that through, this gives us CD being a length of 10.54 and the rest of that there. So this is 10.54. Now that we know that this length is 10.54, using the cosine rule we can work out the length of AC. So this is the second thing I've done here in purple. So the cosine rule allows us to work out a length where we don't have a pair. We can't use the sine rule, but we've got a length, a trapped angle, and a length. So using the sine rule, which is this, so learn this, we're saying that a squared, so AC squared, equals 11 squared plus our 10.5409938 squared from down here, take away 2 lots of the 11 times our 10.54 times cosine of 105. Now working that through and square rooting, we get AC being a length of 17.09 and the rest of this. So we now know the length of AC. Now that we know the length of AC, we've got a pair. In a triangle ABC, we've now got a pair here. So just to finish this off and work out AB, which is our goal, we can go and say that AB over sin 48, so the length that we require over its angle, the 48, equals our 17.091 divided by sin 118. So this over this angle here equals this over this angle here. So just working that through, we get AB being 14.3. Question 18. So we've got to work out an estimate for the distance the train travelled in the first 20 seconds using 4 strips of equal width. So equal width. So our first strip goes from 0 to 5, our second from 5 to 10, third from 10 to 15, and fourth from 15 to 20. Now an estimate for the distance travelled is the area under the graph. So our estimate is going to comprise this little triangle here, then this trapezium here, this trapezium here, and finally this trapezium here. So we've got to add those four areas together. So what's the area of this triangle here? Well, it's half times base times height, so half times 5 times 2. Now looking at this first trapezium, which I'm just outlining there, how do you work out an area of a trapezium? Well, you average the parallel sides, so that's going to be a height of 2 and a height of 5 being averaged, and then you multiply that by the width of the trapezium, which is 5. Now our next trapezium is this trapezium here. We average our parallel sides of 10 and 15 and multiply that by the width of the trapezium of 5. And then finally, this trapezium here, we average our parallel sides of 10 and 18 and multiply that by the width of 5. Now, adding those four areas together, triangle, trapezium, 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 we get an estimate of an area of 130. Now, is this an over or an underestimate? Well, think about it. We've got a triangle here that we've used to estimate, then a trapezium, and so on. Now, if you were just to draw in a straight line there, and the straight line at the top of the trapezium, question 19. So we've got to prove algebraically that the straight line with this equation is tangent to this circle. Now, if it's a tangent, they only meet once. They only intersect once. So what we're going to do, we're going to arrange these, set them equal to each other, solve it, and show that as we've only got one solution, it must be a tangent. So let's start off by rearranging the linear equation, making x the subject. So adding 2y to both sides, we get x equaling 2y plus 10. And then we're going to substitute this into the circle equation. So we're going to replace the x here with our 2y plus 10. So it's 2y plus 10 all squared plus y squared equals 20. Multiply out the bracket, the bracket, so it's the 2y plus 10 times the 2y plus 10. We get 4y squared plus 40y plus 100. Adding that to the other y and the other y squared and taking away 20 from both sides, we get this quadratic equation here. Now we've got a common factor of 5, so I've divided through by 5, giving us this simple quadratic equation which factorizes to y plus 4 equals 0. So as we were expecting, we've got a repeated solution. Question 20. So we know from our circle theories that the angle inside a semicircle is 90 degrees, but this is requiring us to prove this, not relying on any of our circle theories. So to do this, we basically break this triangle down into two isosceles triangles. So let's go and join C to O. Now I think you would really get away by making it really clear in the diagram what's going on, because it doesn't actually say you've got to give a line, write down a reason for each line in your workings. But just to belt and braces it, I've followed up filling in my diagram with, annotating my diagram rather, with explaining it in the narrative just to make sure I pick up the full marks. So anyway, let's follow it around in the diagram before we formalize it down here. So let's choose to, well, we've got two isosceles triangles. So in this first triangle ACO, these are both radiuses, so these are the two base angles of that isosceles triangle, which I'm going to choose to call x. Now, if they're both x, this angle here must be 180 take away 2x, because obviously angles in a triangle add up to 180. And if this is 180 minus 2x, this angle here must be 2x, so that when we add these two together, we get a total of 180 degrees. Now, if this is 2x, and now focusing on triangle OCB, we have another isosceles triangle, because these are both radii. So these two base angles are going to be. Question 21. Now I think this is pretty difficult, to be honest, so let's give it a go. So we've got to, given that MPN is a straight line, we need to find the value of k. Now I think the key point to take on board here is that if MPN is a straight line, then MP must be a fraction of the vector MN. So I'm going to call that lambda. Okay, so MP is part of MN. So I'm now going to focus on working out what MN is and MP in terms of A, B and K, and then I'll revisit this fact in a bit. So let's go and think about the vector going from M to N. Well, that's going from M to O and O to N, which is a minus a half B plus an A plus a 2A, which is a minus a half B plus 3A, which is 3A minus a half B. Now, going from M to P, I'm going to go M to O, O to A, and A to P, bearing in mind that AP is our K fraction of AB, and A to B is a minus A plus a B. So following that through, AP is K times AB, which we were given down here. A to B is a minus A plus B, so AP is K multiplied by minus A plus B,